Okay, so the purpose of this video today is to show you how we can execute and estimate a Malmquist data envelopment analysis technique using DEAP. So the Malmquist DEA is a non-parametric way that we can use in empirical research in cases where we want to measure total factor productivity change, and also in cases where we want to decompose that total factor productivity change into changes in efficiency and changes in technical changes. We can also want to go further to try to understand whether the change in total factor productivity is also arising from pure efficiency change or from scale efficiency. We know that from microeconometrics analysis, we know that there is a difference. From production economics, we know that there is a difference between efficiency change and technical change, scale efficiency change and pure efficiency change. There are marked differences there, which if you are not aware of them, I would advise that you revisit your production economics textbook so that you can have a strong understanding, because like any other technique that is used for measuring productivity, the Malmquist relies so much on the theory of production. Now, but I'm just gonna give you a brief background of the difference between these two. So we know what total factor productivity is, that growth or that increase in output, or the increase in output growth when we have controlled for our conventional inputs, labor and capital. Now, efficiency is all about, particularly when it is technical efficiency, we are simply saying that you have a certain technology that is prevailing, you have given inputs. Now, how much or how is your actual output comparing with the potential output that you can get given the inputs that you have and the existing technology? So if, for example, you intend to measure output-oriented technical inefficiency or technical efficiency, then basically what you'll be trying to determine there is how best or by how much can you increase your output without changing your input combination, and also under the existing technology that would be output oriented technical efficiency. So you will be holding constant your inputs and you want to try to understand by how much you can increase your output. Okay. And then technical change, the difference now between technical change and technical efficiency change is that when we are talking of technical change, we are actually talking about frontier shifts. So we are saying that the production possibility frontier is shifted. That shift is actually a technical change that usually comes with technological progress. So I hope you can see now the difference here is total factor productivity can arise because maybe number one, our firms have moved to closer to the existing production possibility frontier. That's an efficiency change. The technology remains the same, but what is only happening is that firms or companies are now making the best of the existing technology. So they have moved closer to their maximum production possibility frontier. Now, but when it is a technical change, we're actually saying that the existing production possibility frontier is actually shifted outwards, and that can arise due to adoption of new technologies. So firms which were initially operating on the production possibility frontier have shifted outwards. That's a technical change. So the beauty of the Malmquist data envelopment analysis is that it can compute for you total factor productivity change, and it can tell you how much of that change is attributed to frontier shifts, which is technical change, and how much of that total factor productivity change is a result of improvements in the resources, which is efficiency gains. Okay. Now, so let's try to see how we can estimate or execute. And by the way, this technique relies on the data envelopment analysis, which is non-parametric. Remember, when you are measuring efficiency, it's either you can measure it using the parametric way or the non-parametric way. So the parametric way is whereby you invoke methods such as the stochastic Frontier model or the stochastic Frontier analysis, as it is often termed. The DEA, the data envelopment analysis, is actually a non-parametric way. And broadly, it has its own advantages, like unlike the stochastic Frontier model, here the issues of functional form are not really problematic because it's non-parametric. Um, but of course, there are also weaknesses, like you cannot conduct a hypothesis, you cannot make a statistical inference as far as the relationship between your inputs and output is concerned. So heavily, the Malmquist DEA relies on linear programming as opposed to the econometrics that we are used to when we are running the stochastic Frontier analysis. Now, the software that I'm going to use is called DEAP. You can download this software free of charge in a zip file from the University of Queensland's website. You can do that. I've already done that, so I'm not going to do that again. But all you need to do is to go to your Google and type, I think if you can just say the University of Queensland DEAP software, you will see go to that website and download the zip file. It's actually a very useful website. It's helping students across the world. So what I will do is I will use an exemplary data set which I have is here. So this is the example of a data set that I'm going to use to show you how we can calculate total factor productivity change. And I hope you can see from the terminology, from the narrative, that the fact that you're talking of total factor productivity in terms of changes simply means that we are talking of there is an element of time in that. So we have data that has been observed over time across different companies or across different firms or across different countries. It depends actually on the question that you have in hand. But as far as the data set that I have here is concerned, I have a data set which consists of 13 banks. So you can see from this column shows you the number of banks that I have. And then this column here is simply showing me the number of years. So this data has been observed for a period of 13 years, starting from 2000 to 2012, no, to 2015. Okay, so the data has been observed across 13 banks for a period of 13 years. Or in other words, we have observed data on 13 banks, right? But for each bank, we've been collecting data starting from 2003 up to 2013. And if you calculate the number of years there, you find that we actually have a panel data set of actually n is equals to 13 and t is equals to 13. Okay, where in our example this is the number of banks and t is the number of years. Okay, from 2003 to 2015, right? And this is from bank 1 up to bank 13. Okay, so this is the panel data set that we have. T is equals to 13 and n is equals to 13. This is how we, okay, so I'm gonna do a little bit of rearrangement. This is a data set that I got from a friend of mine. So I'm just gonna use it for demonstration purposes, okay? So I'm just going to do some little bit of rearrangement so that before we go to the software itself. So what I need to do here before I do the rearrangements is, when you're using that software DEAP, you have to make sure that the first column here, as far as arrangement of your factors of production, even your output is concerned, you have to start with your output, right? And by the way, guys, I had forgotten to tell you that the beauty of the Malmquist DEA is that, you know, and it's one advantage that it poses over the stochastic Frontier model. With the stochastic Frontier model, you can only use that technique when you have one output, okay? But you can also have cases in which you have many outputs. Maybe they are farmers and someone is farming tomatoes, someone is farming onions, someone is farming maize over a period of time. That person does not have one output. There are about 4 outputs. And in that case, you can't usually estimate the stochastic Frontier model. It won't be appropriate. Or a farmer is cropping, so there is harvest in terms of crops, but the same farmer is also engaged in livestock production. Okay, so you have two completely different outputs. With the DEA, the beauty here is that you can actually measure efficiency of a farmer, efficiency of a company, which is producing many outputs. That's the beauty. Like the data set that I have here from a friend of mine, you can see that there are two outputs, output variables. So these are banks. So by labeling, the dataset is simply saying output 1, and as you can see that output 1 is representing loan to assets, and then you have output 2, which can be something like what can we say, an output in terms of a bank, maybe long-term loans, something like that, or even withdrawals or return on assets and stuff. But the key point is there are two outputs. And we have 4 input variables: input 1, input 2, input 3, and input 4. So I'm gonna do a little bit of rearrangement so that I'll put these two inputs this side. So I will copy, because I don't want to change my friend's original data set. I will open another page. Let me do this. Okay, here we are. So now that I know that this is output 1, output 2, input 1, 2, 3, and 4. Okay, so what I will do now here is I will copy this data set. Right? I will copy this data set. By the way, you have to be careful in making sure that when you are copying this data set, you don't start with the phone. You will just start with the data observations themselves. And it's also important for me to tell you that with the Malmquist DEA, you also have to make sure that your data is expressed in terms of whole numbers, not commas. You have problems. Okay, so what I will do is, now that my data set is arranged, I will go to my laptop to open the software DEAP. I've already downloaded it. It is already lying in my download. Okay, so here it is, DEAP. Okay, so when you download the DEAP, it will be a zip file, right? And then you double click it. When you open, you will see something like this. Right, so let me just try to explain to you what this is all about. Now, this is actually the application itself. This is the user guide. So if you don't know what the DEA is all about, the Malmquist, you can just open this, and then it has some explanations on what DEA is all about. Yeah. Credit to the Center for Efficiency and Productivity Analysis. We have to acknowledge, Professor Coeli. He's really doing a wonderful job. So this is the guide that we have. You can, if you do not appreciate like what I was explaining to you, it also wonderfully explains efficiency measurement concepts to tell you the difference between efficiency change and technical change. You will understand in terms of graph, in terms of technical and allocative efficiency. You will also understand the difference between an output-oriented and an input-oriented, and under what circumstances do you use an input-oriented. Okay, so let's go back. And then what you then see below here, they are actually examples. So what they did actually is they provided some examples that you can follow when you are trying to understand how this works. So EG1 here is example 1. DTA is the data set, right? EG1, INS, they are inputs. So these are inputs based on, for example 1. And this will be the output for example 1. So this is actually a package. On its own, it should comprise 3 things, 1, 2, 3, right? So the first one is the data. The second one is your input variables. The third one is actually it's actually instructions, but the input here is coming in the sense that you have to input something. So don't confuse like inputs in terms of labor and capital. No, it's actually the instructions. You will see as we are executing. That's when you tell DEAP what to do. Okay, and then out will be the output. This is the file that you open to see your output, right? So this is a package, a complete package on its own. Now when you go here, this is now another example. So I hope you can see that example 2. There's a data file and then instructions and output. Okay. So now the easier thing for you to do, one way is for you to one way in which you can do this is to open a notepad, right? So you can open your notepad here. You can open your notepad. So you can open your notepad here and paste your data set here, right? But the easier way, and then you save, of course, and then you save when you put your data, you make sure that you follow these instructions. You put a stroke, a hyphen, and then DTA, right? But the easier way that I want to encourage you is just to find any of these examples so that you can just modify, right? So, okay, for example, let me choose EG2 DTA, right? So it means I will basically have to use these 3, right? But I will start with this one. So if you double click it here, you'll see that it will open, right? To open like this. So the first column, what you need to know is the first column is your output variable, and the second column will be your input variable, this second one. So automatically DEAP will know that the first one is your output. So in this case, you know that you have 1 output and 1 input. It's obvious. So what you will do now is, so I'm just coming here to copy the data. So once I've copied, I'll simply go to this notepad, right? And what I will do is I'm simply going to paste on top of this one, right? Like that. So now you just need to make sure that your data has been entered correctly, making sure this saves a lot of time. I mean, when you compare to a situation where you want to manually type these observations by hand, that will take a lot of time. But pasting is okay, but pasting sometimes can create a little bit of problems, but not always. Okay, so for example, here you might realize that there's a little bit of problem here, but it's not a big problem. When you see this, it simply means that the arrangement is not okay. And to correct that, you simply need to see where the problem is. And I hope you can see that 382 here should actually be in this column. So what I will need to do is I will come here and I will just click to just pushing it one step to the right. And I hope you can see that by doing this, we have rearranged it okay, well here. And then you can do the same for here. It's not necessarily the case that every data set will have this problem. Some data sets will be okay, but some can have even more. You can see that the problem here is actually starting from the second column. So we have to push from the second column. Yeah, there we are. And then again here. Then, okay, so I hope you can see that our data set is now sorted. So now the next thing that you do, remember we are pasting on top of an example that is in DEAP, And if you don't want to override that, you will then come to File and say Save As, so that it will be a different file name. It won't override the one which was existing. So the part that we only need to change is this one, right? So what I will simply say here is I'll say nos. Let me say NOS. Okay. So NOS and the rest, you leave it the way it is. Now click Save. There you are. So if I go here and I go to DEAP, I should be able to find that nos. Where is it? Where is it? Okay, let me check. We should be able to find it here. Okay, seems like it didn't save in the correct file. It's not a problem. Let's just do once again. Okay, let's open EG1 again. We just need to make sure that we paste in the correct folder. I didn't check the folder. That's okay. Or we can simply, okay, I have to cancel it. I'll open again. I'll paste. I'll quickly do the corrections here. Okay, save as. Okay, so let's say NB. Okay, so I'll make sure, okay, it's the correct folder. There you are. Okay, so once you've done this, you should be able to find it here. So NB here, right? So if you double click here, it's supposed to take us to the dataset that we have saved. So make sure that you have saved in the correct folder, which is DEAP. You can, of course, do that in a separate folder. Okay, so now checking. In the second time, I used example 1. Okay, you can use example 2, example 3. But what I want to emphasize here is now we have NB data, right? We are left with NB instructions, NB output, right? So I will go back again to the same package here, but I will go to instruction file. I'll open here. So this is your instruction file, right? So what your instruction file is all about here is, you know, you have to manually tell the software what you are doing. Actually, this is where you tell it what you are doing, the property of your data. So if you come here, your data, how have you saved it? We have saved it as NB, right? NB. Apologies for, yeah, okay. NB. And then, so with NB, we're simply telling it that the data file is called, we've saved it as NB. If you had saved it as NAA, you would type here NAA. And this section is asking us, what name do you want the output file to be, you know, to be given, right? So let's just say NB out again, right? Then here, what are the number of firms? Is 13 here. If it was 1, you need to make it 13. Here, the number of time periods is 13. And then the number of outputs, it's not 1. I would adjust 2. I hope you remember we have 2 outputs, right? And then the number of inputs, we actually have 4. So we change 3 to 4. And then here, this section now is asking us, when we are computing the total factor productivity change, remember it also considers the issue of efficiency and technical change. Now, if you go to the text or to the theory, you will realize that when you're measuring efficiency, or productivity, you can measure it as input-oriented efficiency or output-oriented. Now, the difference I think I've given you, but I can repeat again. You click 0 when you are measuring input-oriented technical efficiency, and you click 1 when you're measuring output-oriented technical efficiency. The difference here is if you are focusing on output-oriented technical efficiency, you are that kind of a person who is saying, holding my inputs constant in the existing technology, by how much is actual output falling short of potential output, right? So you are, in other words, you are a practitioner who is trying to measure the extent to which you can increase your output without changing your input combination and without adopting new technology. That's output oriented. Okay, so for example, if you measure output oriented technical efficiency as 0.8, that would mean that of your potential output, you are only producing 80%, which in other words simply means that it's possible for you, given the inputs that you have and the technology which is existing, it's possible for you to increase your output by 20%. So, but if it is input oriented, you are saying holding output constant or without changing the level of output that you are currently attaining. By how much can I reduce my inputs without compromising the level of output? So I hope you can see the difference here, right? So the choice between this one and this one depends on the problem you have at hand. If you think that output is the endogenous variable, or if you think that inputs are the exogenous, or there are cases where, for example, when you're doing research and you are dealing with manufacturing firms, and when you're dealing with manufacturing firms, maybe the output is fixed, is determined by demand, is already fixed, like people have a fixed amount of millimil that they buy from you, or they have a fixed amount of or there's a fixed number of sales that you make a month, you know, in a given month. So in that case, you will be advised to measure efficiency in terms of input orientation, because you cannot change output. Output is exogenous. You get the point. So the only thing you can do there is to try to determine by how much you can reduce your input usage, maybe to save cost without changing the level of output. That's just one example that I've given you. Okay, now and then so here let's focus on output oriented. Okay, so because I'm assuming that maybe these banks are not producing the output that they should potentially produce given the technology which is prevailing, and also the fact that we are assuming that inputs are exogenously given, right? Now, the second one is, I mean, the second from last, this instruction is about returns to scale, right? It's about returns to scale. So it's critical for you to make a decision here. And what you need to know is when you go to your theory of the firm or the production theory, you will realize that, and this is very, very important, as I said earlier, that the Malmquist productivity index or the Malmquist approach, it actually relies on a production function, although it does not estimate in a parametric way, but it does make some assumptions in terms of the production function. So one of the assumptions has to do with returns to scale. So do you expect in your case to have constant returns to scale? Do you think that the constant returns to scale assumption is plausible? That depends on the problem at hand. Maybe if you think that you're dealing with banks which are operating under extremely perfect perfect competition, then you might assume constant returns to scale, because when you have constant returns to scale, you're implicitly assuming a higher degree of competition. Okay, but when you otherwise you would need a varying or variable returns to scale, where you can have increasing or decreasing or constant returns to scale. Okay, so you can only choose constant returns to scale when you feel that the environment is competitive enough. So I would choose 0 because I think that banks are operating in a perfectly competitive environment, given the emergence of small microfinance institutions, these credit and loan providing small firms. And then the last part now is asking you, are we using multi-stage cost DEA, DEA one stage? We want Malmquist DEA 2. So we just put 2 here. It's already 2. When we are done, we save as. So let's save as NB-ins. There we are. Okay. When we are done, we should be finding NB-ins here. It's taking a little bit of time. So here we have NB data and NB-ins, right? The last part is NB out, right? Which would be, in this example, it will be EG1 out. Now, for you to do that now, you don't come here to click here, no. You will then go to the application itself, right? So you go to the application itself, we run. Here it is. So you simply type NB ins.txt. Okay, so this NB, so this is the instruction that we're giving. NB, that's the name of the instruction. NB is the name of that we have given to our instruction file, right? And then click enter. Right. We must have made an error. Let's copy again. It's so sensitive. Programming is so sensitive. Okay, let me just go to, okay, it's NB. Okay, NB ins txt, right? Right, there we are. So automatically you see that we have NB out. So this is our output, right? We double click it, we see our results. So here are our results. Okay, so these are the summaries, the DEA summaries, year 1, but we will go to, we will scroll down up until sorry, it's my friend who is actually calling me. Okay, let me just answer my friend. Hello? Yes, how are you? I'm fine. Do you mind giving me just 5 minutes? I'm rounding off the video now. Yeah, just 5 minutes, yeah. Okay, thanks a lot. Okay, so I was saying that, okay, so we will scroll down up until we get here. Malmquist indexed summary, right? Malmquist index summary. So you will see that because it's in terms of changes, you lose the first year. Okay, so our output of interest begins here going downwards, right? So you can see firm here in our case, that's the banks. So we have bank 1, bank 2, bank 3, bank 4, bank 5 up to bank 13 in year 2, right? So this was the change in total factor productivity in year 2, from year 1 to year 2. Okay, so for the first bank in year 2 must be 2004, right? So in 2004, the first bank grew by, so TFPCH is total factor productivity change. So it's effective because this is an index, right? So if you multiply by 100 and then you minus by 100, you find that basically what this means is that the bank 1 increased, or it experienced an increase in total factor productivity change of 4.5%. Okay, so total factor productivity change increased by 4.5% for the first bank. And then for the second bank's total factor productivity grew by 5.5%, this one 8.7%. And the bank 4, it actually, when this one is less than 1, it is actually a productivity decline, right? I hope you understand. So wherever you see, so this one and this one, they actually experienced a productivity decline because it's a less than 1. Okay. Now, so these are total factor productivity changes. So I hope you can see that the bank that grew very fast, can you say fast? I don't know if it is the correct grammar there, but I think the bank that experienced a larger productivity increase, a large increase in total factor productivity, is actually bank 11, if you can see, because it grew by 35.5% in 2004, or year 2, right? Then when you come to this column, okay. So if you come for bank 1, it's actually telling you that where it can actually tell you where the 4.5% came from, right? Remember, we have said that bank 1 grew by 4.5%. And the beauty of the Malmquist is it breaks down this total factor productivity change into changes in efficiency and changes in technical changes. This is efficiency change and technical change. So this is a shift in the frontier or technical progress, and this is a movement towards the production possibility frontier. So you can see that the 4.5% was actually a result of technical changes. So this bank 1's total factor productivity grew by 4.5% as a result of technical change. So it adopted, modern practices, technical practice. So it's mainly because of technical progress and not improvements in efficiency. Okay, so and then you go to the second one, the same. You can see, right now. Still on year 2, you can see the mean. So on average, these banks grew by 7.1%. So the total factor productivity of these banks on average grew by 7.1%. And this 7.1% was largely a result of what? Of technical changes. So these are it's merely technical progress, which was the driving factor of total factor productivity change. Otherwise, there was actually a decline of technical efficiency. So we can't say that they became more efficient, that's why they grew. No, actually they actually became more inefficient in the way they operate. But the good thing is they were inefficient but using advanced maybe production techniques. So technological progress in this case was the main driving force of total factor productivity change. Then you go to year 3. Year 3 again, you will see the same summary. So in year 3, this one the first bank grew by 7.9%. This one experienced a productivity decline, the same. This one grew by 45.5%. This one, it declined. Total factor productivity declined as well. So you can summarize it as, okay, so we have this number 1, 2, 3, 4, 5, 6, 7. So when you're summarizing, so 7 banks in year 3 experienced positive total factor productivity change, while the remaining banks it actually experienced actually a decline in total factor productivity, but on average, a typical or an average bank grew by 6.8%, which was less than the 7.1% growth experienced in the previous period. And again, you can decompose this into changes in what? Changes in technical efficiency or technical changes. And you can see that even in year 3, much of the total factor productivity growth is mainly driven by technical changes, right? So you can do the same going on and on and on and on and on and on here. So in year 4, there was a decline in total factor productivity from 6.8 actually declined. And then here they recovered from the decline to actually register a 2% increase in total factor productivity change. And this 2%, interestingly now, I hope you can see an interesting result here is now this time, which is in year 5, the recovery in terms of total factor productivity from this decline in the previous period was mainly a result of efficiency change. Understand? I hope you can see that this time efficiency gains were 3.5%, but they actually regressed in terms of technology. Okay, so there was a technological regression here. Yeah, so in other words, what this means, that what this would mean in theory is like they actually moved backwards in terms of the production possibility frontier. Okay, so the key observation here is in year 5, the 2% gain in total factor productivity was mainly driven by efficiency changes, not technical changes. Okay, and then you go to year 6. Year 6 was mainly, on average, 7.5%, which was mainly driven by technical changes. So now it then depends. Okay, so you do on and on and on. You can interpret it using the same way. Actually, there's a lot of, and then this is the means. At the end, you find the means. So bank 1, on average, this is now the average for the entire period. So between 2003 and 2015, right? The first bank experienced an increase in total factor productivity by 4.8. The second one, 1.9. The third one actually experienced a decline in total factor productivity. The third one grew. So you can say that on average between this period, 1, 2, 3, 4, 5, 6, 7, 8, 8 banks experienced an increase in what? In total factor productivity. And on average, there was an increase in total factor productivity of 1.5%, which was mainly driven by technical changes and less by technical efficiency. You can also report in terms of pure efficiency changes and scale efficiency changes, right? So it now depends on the objective of your study. There are certain studies which would need to proceed to the next step to determine the determinants of maybe efficiency change or technical change. The disappointing message that I want to give you is you would need to then write these down. You need to copy these down and write them separately as variables in your Excel. Because like I said, it depends on the objective of your study. Some studies are actually aimed at just producing this kind of output, which is just measuring and explaining. But there are studies which can go beyond this to determine how maybe research and development expenditure affects total factor productivity changes. In that case, you would need to take again these results and put them in Excel. And you should be careful in making sure that firm 1, so for year 2, you make sure that the first bank you put the correct figure. And then year 3, you put the correct figure for the correct bank, so that you make another panel in Excel, which will then allow you to take another external variable, maybe research and development or human capital, and then you run in another regression where you can now determine how human capital or maybe research and development affected total factor productivity during this period. So it depends on the objective, but as far as measuring total factor productivity changes using the Malmquist is concerned, you will be done at this stage. So thank you very much.